All right, we're going to go ahead and get this webinar started. I want to start out by saying good morning to everyone, and thank you for being here at today's webinar, Waste Heat Bottom Line, presented by ElectraTherm. This will be the first in a series of webinars in which we'll present ideas and concepts related to how waste heat recovery can deliver bottom line benefits. Again, thank you for being with us here today. My name is Ashley Edge, and I'm the marketing coordinator at ElectraTherm. Today's webinar episode topic is waste heat to power solutions for reducing methane emissions at natural gas compression stations and how ElectraTherm products can provide simple and effective solutions that utilize existing waste heat streams and turn them into continuous revenue streams and operating cost reductions. Before we get fully started, I'd like to go over a few items so that you know how to participate in today's event. The audio video feature has been disabled for attendees, but the chat box will remain open during the presentation. You will have the opportunity to submit text questions to today's presenters by typing your questions again into the chat box of this event. You may send in your questions at any time during the presentation, and we will collect them and then address them during the Q&A session at the end of today's presentation. Also, one more note, if you would like a copy of today's presentation or a copy of the webinar video, please send us an email request to sales@electratherm.com upon conclusion of today's webinar. We're going to begin today's presentation with why, the purpose. Following that will be the company overview, then our ORC technology, then we'll go over ElectraTherm's product line, active cooling in the field, the benefits, and then at the very end, we'll have a Q&A session to answer all of your questions that you submit throughout the presentation. Now we'll pass the presentation over to Jesse Howell, sales manager. I'm passing it over to Matt Lish, the managing director with ElectraTherm. Thank you.
Good morning and welcome everybody. Thank you for attending this first in a series of webinars on ElectraTherm and how we enable businesses to turn with their waste heat streams into profitable and revenue streams and to support their core business. Methane, I'm not going to go into details. I think everybody on the call understands that the urgency for the oil and gas industry to reduce their methane emissions, to address current and impending government oversight from and reporting regulations, both for federal and local governments, and also equally importantly, financial institutions that fund and fuel the growth of our business. Go ahead, next slide. So when we look at natural gas compressor stations and speak to our many interested customers, there's two themes that we see in our discussions. One, it's a given that they're all trying to attack their scope 1 methane emissions from their compressor stations. How are they doing so? By utilizing electric air compressors to replace leaky valves that emit methane and replacing them with pneumatic valves, air-driven or electric starters for your compressors, as well as vapor recovery units. And you'll see a common theme and how what we believe we tie in here is the need for more electricity at compressor stations in order to reduce scope 1 emissions. We see all of our customers are focused on that. The other theme that we see, I just labeled it as what else. It seems that oil and gas companies are evaluating, call it a research phase, evaluating all sorts of technologies with the common goal to reduce emissions and or greenhouse gas or carbon footprint of their facilities. And we believe that the reason we're here today, we believe that the solution that makes the most common sense that to your business is to utilize your waste heat that's already at your site, at your many sites, to generate continuous, clean, emissions-free power generation in order to enable your methane reductions. But it also has other contributions and value to your business. And it's really the business case for utilizing your waste heat that I want to, I'll spend one more slide going into. Go ahead, next, please. Okay, why does it make business sense to utilize your waste heat? As I mentioned, you can lower your scope 2 emissions simultaneously with your scope 1. We know that you're all already working on your scope 1 emissions by replacing valves and starters, like I mentioned. Why not reduce your scope 2 at the same time? Make your sites actually energy neutral. There's enough waste heat at compressor stations along natural gas pipelines that they could actually generate equal or greater power depending on how much heat you want to recover. There's plenty of waste heat at these sites. Number 2, you can improve the reliability and uptime. We all know that is everything in this business. There are several applications and times when recovering the waste heat and our product, and Jesse will go into this, actually can provide redundant cooling. So if you ever have any sites where cooling is a challenge or a problem for your engines, implementing an ORC, organic Rankine cycle, and Jesse will go into that in detail, and the cooler that comes with it actually provides redundancy to your site. Number 3, generating your on-site power from your waste heat lowers your operating costs. It's not just an ESG play, but lowers your operating cost of your sites. Also, going forward, it becomes predictable. That is, that you control your energy costs. You're not at the mercy of the grid or your local utility if you control your energy costs. Any financial manager of your businesses will find that attractive if you can say, you know, I'm going to recover my heat and either buy no power from the grid, or I know exactly what my operating costs will be going forward, is attractive to any financial manager of a business. Number 4, it supports growth of your core business of compressing natural gas and moving up a pipeline or collecting it and distributing it. Flexibility, number 5. Our solution is scalable. You can start small and recover just heat from a jacket water or just heat from exhaust gas on one compressor, and easily can be scaled up to recover 100% of the heat from your site, from 100% of your engines. Depends on how much power you have a need for or how much you can sell. It's repeatable and can be repeated at multiple compressor stations, and movable. It's a very attractive option for contract compression companies. You'll see that our equipment, as in the picture behind me and many of the pictures, we can skid the equipment and you could move it between sites, just like you do when you use contract compression. And lastly, the last point I would say why recovering your waste heat makes sense business-wise is you can create new revenue streams. Many of your options that people are looking at right now to meet their ESG commitments do not create revenue. And if you compare it to generating your own power on site with no risk to your operation, it creates a pure revenue stream. You can sell the power. If you don't want to just utilize it yourself, you could sell the power to a grid. You could sell the power to a neighbor and do a PPA with a facility or somebody next to you. You can do vehicle charging stations. We see a lot of interest in doing that, both for buses or cars or forestry equipment. Several markets are interested in locating vehicle charging stations where they can find energy. And lastly, an idea we're talking to people about is crypto mining. Crypto mining, if you're not familiar, already utilizes more energy than all the refrigerators in the United States. So why not turn natural gas pipelines, recover the heat, and do crypto mining and generate revenue on site? That's, in a nutshell, I would say, be the strongest arguments for waste heat recovery. And now to get into the details of ElectraTherm's solution and how it is done, I'll hand over to Jesse.
Thank you, Matt. First and foremost, I'd like to thank everyone for joining us today. We've got a lot of exciting things to talk about, so looking forward to it. So ElectraTherm has been engineering world-class waste heat to power systems since around 2005. If you're anything like me, you think, well, 2005 wasn't that long ago. Well, Jesse, 2005 was 17 years ago. So we're approaching 2 decades of engineering and producing world-class waste heat to power units. Now, our Power Plus generators of their current rendition was commercially released in 2011, and in 2016 we are acquired by Bitzer Group. That's a key point. Bitzer is a large company with around 3,400 employees and $1 billion in sales. They're actually the world's largest independent manufacturer of refrigeration compressors. And the key to that is it allows us to be flexible with ElectraTherm being a relatively small company and focused. So we have a standardized product, but we can be flexible in working with clients and designing specific solutions for sites, because that's what we are. We're a solution provider, but we're also large enough with Bitzer ownership and support that we can support all of these units in even some of the most remote of locations. Bitzer's semi-hermetic twin screw expander is actually the centerpiece of our ORC system. So it's based on refrigeration compressors. And in that sense, our equipment is more similar to an appliance rather than a power generation device. Although what we're making is power, in regards of operation and maintenance, this is more similar to your refrigeration type appliances. So as mentioned, we successfully commercial released the Power Plus systems in 2011. Install base is over 100 installations globally now, operating in 13 countries on 3 different continents, and approaching, or actually slightly over 2 million operating hours now. As mentioned, since we have the support of Bitzer, we're able to support these projects even in very remote locations. So oil and gas sites can be fairly remote, but we've also got sites in remote areas of Europe and in Unalaska at Dutch Harbor, actually operating on several engines out that way. So able to support all of those projects and a fairly comprehensive install base worldwide. So ORC technology, organic Rankine cycle, as we're calling it, waste heat to power, can provide a lot of things for clients. So our end product is electricity, but we're also providing a proactive environmental, social, and governance initiative approach, tangible carbon reduction and flare elimination cases, which we'll talk about a little bit later, the ability to utilize resources more thoroughly and increase efficiency, and of course save energy and fuel consumption at that point. And then these units are available or are eligible for a 26% investment tax credit currently from the Consolidated Appropriations Act of 2021. There's also the possibility that the Build Back Better plan will have an additional 10%. And these are for projects that commence construction prior to 2023. So important to note about that 26% investment tax credit is that not only applies to the waste heat to power equipment, but also any associated equipment related to the installation of it. For instance, if you needed a heat exchanger on site because you wanted to do exhaust heat and yield high results, that 26% investment tax credit would apply to that. Or if you needed some installation pylons or pumping, it would apply to that equipment as well. So significant savings. So how the technology works, it's actually a very simple cycle. What we're doing is using heat to boil refrigerant rather than hot water. So it's similar to steam power generation of yesteryear, only we're using an organic refrigerant in the evaporator. So our refrigerant is non-toxic or low toxicity and non-flammable. And we're heating that with your heat source. So under pressure, that's going through the expander that we talked about earlier. That's very similar to a refrigeration compressor, which spins a generator and produces power. Now, this is a closed loop system with this refrigerant, so that vapor is cooled and condensed back into a liquid, and then we pump it to a higher pressure and return it to that evaporator. We return it to that heat source. I like to think of it similar to refrigeration technology still. With refrigeration technology, you're using electricity to spin a compressor to condense it and cool things. We're doing the opposite. We're using heat to expand that refrigerant and spin an expander, which turns the electric generator. So a very simple system, and I would encourage you to visit our website and our YouTube videos. We've got some very informative videos on how it works, but also some more details on the technology and some interesting information on other videos as well. So I would encourage visiting the website for those. Now, what that means in a nutshell is, yeah, that's how the process works, but what we're doing is converting heat to power or heat to efficiency. And emission savings or heat to power for your scope 1 emissions reductions. So heat can come from a variety of sources, particularly at midstream compression sites and all compression sites. So heat from internal combustion engines or compressor heat could be utilized for power production. High efficiency cooling, so combined cooling and power, that's where we use engine jacket water at lower temperatures than what most heat recovery is capable of. We can operate down to even 150-degree Fahrenheit heat sources. So that's where we function as high efficiency cooling, but also process heaters. So if a site flares a lot of gas, we can eliminate the need to operate that flare by using a process heater and an ORC system. And then geothermal resources. So a lot of oil and gas sites have some form of geothermal resources, some even approaching 200 Fahrenheit, that can be very viable and reasonable for power production from that heat. So, I mean, the biggest thing we want to talk about today is that we are also focusing on methane intensity reduction. By adding emission-free site power, you're able to use that electricity for a variety of ways, including the use of vapor recovery units and pneumatic valving to reduce those scope 1 emissions like we talked about. So it's simple. When you have an engine of greater than roughly 800 horsepower, then we can lead to up to a 10% increase in working efficiency, but also electricity up to 150 kilowatts gross. So net outputs that we're capable of are around 110 kilowatts. But it's simple, and this heat comes to the system in a variety of ways, which we'll look at in a bit. Our current product line consists of 3 main products and then several more in development. So currently our largest single system is our 6500B and B plus units, which produce up to 150 kilowatts gross. That's at 60 hertz. And then our 4400B systems that produce up to 75 kilowatts. And then our active cooler, which we'll get in a lot of detail on. Our active cooler is designed to reject roughly 800 kilowatts of thermal energy and greater. And it's based off of the platforms of those other 2 existing systems. As we get into more details on the active cooler, I'll highlight that is always on cooling. And of course, it's not a one size fits all with regards to heat rejection. So I mentioned it gets its name from 800 kilowatts of heat rejection. That's what it utilizes for power production. But if you have an engine that has, roughly 1.2 kilowatts thermal, or yeah, then 1.2 megawatts of thermal energy, then we would be able to reject that as well. So the active cooler is our newest product. Everyone knows that engines and compressors produce heat. Radiators typically consume power until now. So we use an active cooler to reduce carbon footprint. It does qualify for the 26% investment tax credit currently. And it's simple. It's hot water in, electricity out, and then the cooling circuit of the engine is taken care of. So what we're doing, we're using that jacket water circuit of compression engines to make power with our system. And we are also always on cooling. So if the unit is not producing power, maybe you have a site that runs at a partial load. So it's running at 50% load, and maybe it's a smaller engine that doesn't have quite enough heat for power production. Well, we would still be able to cool that engine and maintain operation, because first and foremost, the main goal of our active cooler in any Power Plus system is to not interrupt operation. So it is always on cooling. Installing these units is very similar to a radiator installation. So it's a hot water supply in return, and then a motor rated circuit breaker for your electrical connection, because we utilize an induction generator. So it's very similar to installing a motor of equivalent size. So if you were installing a pump that was roughly 150 kilowatts load, that would be the type of breaker you would need for a 6500. Now, it does say cooling water out on this slide. What we mean by that is the cooling water for the engine. So if you have an engine that operates with 190 degrees, typically going out to the radiator and a return of 170, we can guarantee that return temperature no matter what it is. So we see a lot of different applications, whether it's Cat 3600 series engines or some of the Waukesha Richburn engines, or even MTU or Jenbacher engines. We're capable of guaranteeing those return temperatures to the equipment. So in the field, active cooling is becoming very popular across the globe, but you can see on the left here, we've got a natural gas compression site near Oklahoma City that's actually cooling the jacket water and making power. And then the unit installed on the right there is at a biogas plant in Poland. So they're actually using exhaust heat too in that system to make power, but they make a considerable amount of power for that site. Now, the site in Oklahoma, another thing I'd like to add about that is that was a site with a PTO-driven fan and a 5-circuit radiator. So it does illustrate that it is possible to remove the jacket water circuit from those radiators or coolers and eliminate a lot of that parasitic load there. There's also potential to free up horsepower in those applications, but sites with electric fans, you're offsetting the need for that load as well. So I talked about, okay, we're making power with the active cooler, but we're also eliminating a parasitic load of your existing cooling source, whether that's horsepower or whether that is actually electricity for electric coolers. You have that benefit as well. So for example, if we're coupling to, say, a Cat 3616 engine, and we're making 50 kilowatts from jacket water, great, we're making considerable amount of power. Well, if it was on electric coolers already, then we're also eliminating, say, 10 to 20 kilowatts of electric load that's already at the site. So you're actually netting 60 to 70 kilowatts at that particular site just from the jacket water. Now, we have optimized this system for oil and gas applications. I really like this photo because you can see the hot water supply and return to the right side of the photograph and the very robust ruggedized sled. That also serves a purpose for easing installation. So there's no significant foundation requirements for that. And it's automatic cooling independent of power generation, as mentioned previously. We've designed the system to have minimal water side pressure drop. So it's designed to be exactly similar to a radiator. In the sense that you can use standard pumps. Typically in most applications, you wouldn't have to upgrade. Also, as mentioned earlier, I think Matt alluded to it a bit, we're also capable of redundant cooling, but also eliminating derate potentially at sites. So some of those sites out west in the stack shale play experience summertime derate. We have additional cooling capacity compared to a lot of standard coolers because we're cooling our refrigerant to a much lower temperature than that delta or difference that you have in engines. So if engines are going from 190 to 170 degrees, we're dropping our refrigerant down much lower, many times within 20 degrees of ambient conditions. So with that sense, our cooler is actually oversized for the engine because we are cooling it for our power production process. So these units are a simple solution for immediate action, and also there's multiple ways to integrate power from waste heat at oil and gas sites. So looking at a typical installation, we can make roughly 30 to 50 kilowatts of power from 1 megawatt of heat in the engine jacket alone using the active cooler. We can also utilize that exhaust heat to make a considerable amount of power. When we're looking at exhaust heat, an exhaust gas heat exchanger or heat recovery unit is required. However, we're able to make a lot more power because we're using a higher temperature from that exhaust. So we're exploiting more of a difference between our heat source and the ambient conditions. So some good examples, I've looked at some sites recently where they have enough heat for 150 kilowatts just from the exhaust of a single engine. Some larger engines might be capable of powering 2 of our 6500Bs, which is important. They can be operated together and also produce, say, 300 kilowatts at those potential sites. The benefit of running multiple units together and of our screw expander is that we're able to operate at a much higher turn down than a lot of other technologies. So this equipment can operate at a 10-to-1 turn down. So if you look at it from the ways of conventional power generation, about 10% rated output, that means that we're able to make power and cool equipment through a wider range of processes. So your typical power generation equipment can only operate at about 50% rated output. Below that, for extended periods of time, typically doesn't function quite like designed. Our equipment has no issue with that since we're utilizing that Bitzer expander. It's more than capable of operating through a full range of inputs from the heat source. So if you have, again, engines that operate at variable loads or full out, doesn't matter, our units are going to operate continuously within that time. So for powering off-grid sites, we can actually become a key cornerstone or even the centerpiece of a microgrid. So since we're coupled with the heat source at these compression sites, a lot of which run and operate at as much runtime as you could see anything, so 95, 97% uptime, we're base load power at that point. So as long as your unit is operating, we are producing power from it, so becoming the base load before that. Currently, utilizing this equipment for off-grid sites, since we're utilizing an induction generator, you would couple this equipment with batteries and inverter systems. We're also working on standardized packages expected to release in 2023 for island mode sites, so sites that don't have any site power whatsoever. But we're able to generate, and then when coupled with batteries, you're able to store some of that power to mitigate the ebbs and flows or peaks and crests of, peaks and troughs of power consumption. So able to work with demand more streamlined. So with that and focusing on those heat sources and how we're able to operate and store that power in islanding sites, we're able to power things like electric radiators. So sites that have electric gas cooling, we're able to offset a lot of that load, or in some cases all of it. We're able to power air compressors, and of course the pneumatics can be used for vapor recovery units like we spoke about earlier. Or even operational benefits, so maybe heat trace or snow melt. Different site power requirements that it would just be nice to have. Maybe safety lighting, in addition, could be powered by your heat that's currently underutilized. So flares, to talk about flares a little bit, flares are a glaring reminder of an underutilization of resources or something that we could utilize maybe a bit more. And it's obvious and visible. Obviously, flaring is better than just releasing CH4 into the atmosphere, but it releases large amounts of greenhouse gases that are contributors to global warming. So whether it's nuisance or constant flaring, we can provide a solution to solve these problems. As mentioned earlier, we can operate at a 10-to-1 rated output. So whereas traditional power generation might struggle with flares or full elimination because they struggle at partial load, our equipment again can operate down at a much reduced load. And if you're coupling multiple units together, it's even more. So for instance, if we had say 3 6500B units and you're looking at over 300 kilowatts of production at full output, in some instances, if your flare gas quality or quantity went down considerably, you wouldn't lose all of those systems. You could still operate down all the way down to 15 kilowatts of output, which is significant because conventional power generation would be unable to do that for extended periods. So we did do a study in the Bakken Shale here, working in tandem with a boiler, and it was a Texas A&M study. So from their Institute of Renewable Natural Resources, just by removing the enclosed flare and adding a boiler system, it reduced carbon monoxide emissions by 89%, NOx by 48%, and VOCs by 93%. So it does allow us to not only reduce and eliminate flaring, but exceed air quality standards, and then generate additional power for site loads, whether it's pump jack controls, wellheads, or as I mentioned earlier, heat trace, or switching to pneumatic valving. So that was actually a HES study there. We will be doing another presentation or webinar later in the year on flare elimination as well, so be on the lookout for that. So factors for successful application. The great thing about factors for successful applications are that oil and gas sites, particularly compressor stations, have all of the factors. So heat. Do we have enough heat, and is it at a high enough temperature? The temperatures commonly found in compression engine jacket water are more than significant for and more than viable for power production. So we can make significant power in most instances. Even with some of the rich burn Waukesha engines that run at a much lower jacket water temperature, they can be a great fit. Being rich burns, they typically have a bit more heat. Also, exhaust heat's there. So exhaust heat on some of these larger engines, we can get up to 300 Fahrenheit and make, max out those 6,500 B systems. So run hours. Most compressor stations and midstream sites generally have extensive operating hours. The more it's operating, the more gas you're moving through the pipeline, the more power we can make at the same time. So it's a great fit with regards and complementary in terms of run hours and the value of emission-free power. So, we often look at the cost of power and we think about, okay, this is what we buy the power from the electric company for, but also, maybe that's not always the best way of looking at it. Sometimes avoiding additional costs can be an even greater benefit and optimizing operations. So not only are we making emission-free power, reducing site footprint, there might be an instance where a site needs to add more power generation. Maybe it's an off-grid site operating off of microturbines or reciprocating engines. You could use the heat off of those systems to make more power rather than adding additional power generation for just a bit more load. So if there's capacity limitations at certain sites, sometimes you can avoid the cost of adding additional equipment just by utilizing that waste heat. And also adding just enough power for pneumatics and vapor recovery units, a lot more added benefit there in avoiding additional future costs. So the units are very good for business because they're simple, reliable, profitable, and sustainable. So the units are very robust. Again, I compare them more, very robust and reliable. I compare them more to refrigeration compressor type technology. They're more of a set it and forget it type appliance. So when they have heat, the units come online, start producing power. When that heat source disappears, the units go offline. When it returns, they start up again. It can be a hands-off approach. The units are modular and scalable and very easy to install. Again, very comparable to a radiator. So a hot water supply and return, and then a motor rated circuit breaker for your electrical connection. So since we're using existing heat as fuel, operating costs are minimal. That's one of the biggest differences in our equipment in terms of total cost of ownership. There is no fuel cost to operate this besides what you already have. So again, we're using that to offset energy costs, but also just further utilize existing resources. And the units are very sustainable. They're an easy way to mitigate emissions and achieve those environmental, social, and governance goals that we mentioned previously. So the results are quantifiably good for the environment. Taken straight from the EPA calculator of greenhouse gas equivalencies, adding 5 active coolers, is roughly the equivalent of taking 500 cars off the road. So putting one of these on an engine is like taking 100 cars off the road for a year. It's equivalent to the carbon absorbed by a 3,000 acre forest. And that's just the active coolers. If we were coupling 5 active coolers with engines, those engines are also of a size large enough to utilize exhaust heat recovery as well and produce even more power. So there's a number of operational benefits for the system. First and foremost, the system is engineered for engine cooling and designed specifically with regards for not disrupting operations and making sure that we guarantee the supply and return temperatures necessary. We're not using any additional fuel. It's a measurable reduction of carbon footprint, increasing overall site efficiency. I've actually seen sites, not oil and gas sites, but prime power sites where adding waste heat to power to an engine would eliminate their need for selective catalytic reduction or expensive emissions technology. Also, again, mentioned earlier about capacity, we're adding new electric power. So it's not only is it methane intensity reduction, but it's also possible to provide power for new site loads that maybe weren't thought of when the site was greenfield. And then we provide redundant cooling and derate elimination. So again, we're cooling our refrigerant to a lower temperature than what the engines require. So we're able to cool those engines more significantly. So if sites are expecting some summertime derate on the hottest of days, we can contribute to reducing that derate or providing redundant cooling. If a site already has a radiator, Maybe that radiator's left as backup, so we would just be there for redundancy, but also to produce power, and then you'd have that cooler as the backup. With regards to derate elimination, as long as that derate is off of jacket water temperature, we can help eliminate it, and we can also cool the intercooler circuit as well, the low temperature circuit. So the low temp circuit doesn't allow us to make power, but it is significant for cooling. So with that, I'm going to turn things back over to Ashley for our question and answer session.
Hello, thank you, Jesse. Thank you both Matt and Jesse for the captivating presentation on waste heat to power solutions. We're now going to begin answering the questions submitted by the audience during today's presentation. As a reminder, you can still submit questions through the chat box. The first question that we had was from Mr. Munoz, and he asked a couple of questions regarding the optimum output, and I will let Matt take over on that one.
So again, my understanding, and I will punt over to engineering to get you a more specific answer after the presentation if needed.
Matt, you're muted.
You know, if there's a specific.
All right, that's great. The next question was from, I'm sorry, I lost it. Is it possible and useful to start with heat from 50 degrees Celsius? Matt.
50C, I see.
Okay. All right. The next.
Matt, Ashley and Matt, you've been muted during the last two questions. We did not hear either answer.
Tom Brokaw, head engineer, answered it in the chat window, but 50C is a little low to generate power, but 70C is a good minimum rule of thumb to start generating good power with our units. But as Tom mentioned, we are looking at new fluids and lower temperatures for future equipment. But with our current product line, think of 70C as a minimum to start generating.
That's great. All right, our next question is what refrigerant do you use in the system? And then a follow-up question to that was, what are the main reasons for limiting the temperature to 150 degrees Celsius?
The refrigerant is R245FA, and it is a non-flammable synthetic refrigerant made by Honeywell and large refrigerant companies. The main reason for limiting the equipment to 150C maximum, Mr. Vasudhavan, shoot me an email or to the, I don't know the answer to that right now, but we will get you an answer to that. I assume it's a limitation within the equipment somehow, but we will get you an answer. And then what is the efficiency at 70C? Again, it depends on the delta T between the hot side and the cold side. And then as far as what is the CapEx per kilowatt, send us an email and we could talk applications and get into pricing, just not this point.
All right, our next question is from Natalie, and she asks, what is the footprint of the units?
I believe the small unit is about think of an 8 foot by 8 foot by 8 foot cube. The 6500 is a little bigger. And then a fully integrated AC 800 with cooler. We should have specs on the website. I believe it's just under 40 foot long by 8 foot wide, designed to fit into containers as well as the skidded solution would fit on a typical flatbed truck.
That's great. All right, we have another question, and that is, what information do you need to determine if my compressor engines are fit?
The spec sheet of the compressor, of the engine, and then in certain cases, we do need to go on site to measure full temperatures and flows. But generally, we can size based off of the heat recovery off of the manufacturer's spec sheet.
And Robert just sent in a question, and his question is, how does the system react to energy fluctuations, either on the input hot side or the output cold side?
Good question, Robert. An ORC system, particularly ours, because we use a screw expander as the heart of the system, gives us a 10-to-1 turn down, which is industry leading, and allows us to react to those fluctuations seamlessly. As the temperature in or the cold side varies, the unit is designed to create maximum power given those heat conditions, and it reacts very quickly. And this is something that we can even demonstrate for you. And we always encourage customers to come to our site, to the plant, and see our test station where we run units and let them vary the loads themselves and demonstrate how our units react. It's something we're particularly proud of.
That's great. All right, our next question would be, would it be practical to use a flasher prior to passing the heating fluid through the ORC? Through our ORC if temperature is 150 degrees Celsius?
I don't know. I will have to get you an answer to that after consulting the engine.
And then our next question is, how difficult is it to connect to the grid?
My understanding is it's very simple. To connect to the grid, we use a synchronous generator that makes it, and the reason we do that is to make extremely simple installation of our units. It's basically one wire in and out. We do need the grid to push against. It's the nature of a synchronous generator that we use, but very simple to implement and even to export. And then usually the next question we receive is about safety, and an advantage of the synchronous generator using the grid to push against is if the grid goes down, our unit goes down. So generally you do not have to worry about our unit continuously running and hurting somebody who's working on the grid locally. And as Jesse mentioned, next year when we come out with islanding, there's a series of inverters and batteries that are involved to do an islanding. And then there it gets a little more complicated in connecting to the grid, but it's something that we've done in Europe and we will be able to do here next year.
Great, that was our last question. Does anybody else have any questions that they would like to submit through the chat? We can answer them right now. All right, we got another question in. Natalie asks, what are the anticipated maintenance requirements of the unit annually?
Very low. I can't remember how many hours, or 4 or 5 years, depending on vibration measurements. You do swap out the expander, but the unit is designed to be for what refrigeration or maintenance tech would call a lift and shift, to make it very simple with minimal downtime. But the maintenance is really no different than your normal commercial air conditioning unit. There's some filters, etc., but no extensive maintenance, and it does not. Our units do not require on-site operators of any kind. And we teach all of our customers. We do extensive training here at the factory, how to perform the maintenance themselves if they wish. And we also provide online support. We can connect to the unit and guide anybody doing maintenance on the unit remotely.
That's great. All right, our next question is, how is my engine cooled if your generator goes down?
Good question. We talked about the AC800 that you can see behind me and Jessica spoke to at length. The engine, if you leave the engine cooler that in place in a brownfield or an existing site, and you attach ours, it basically gives you redundant cooling. So if your cooler is already has a PTO driven cooler on it, it keeps on running. And if our unit, the AC800, is designed, if the ORC portion, the power generation, the box in front over here goes down, you still have a cooler behind it, and that keeps working. And while running controls the temperature back if you're using jacket. So we really do believe you're adding to the redundancy and reliability of the site by actually adding the additional cooling that also generates power for it.
That is wonderful. All right, let's see. All right, we just got 2 more questions. All right. Azelle said, apart from the simple annual maintenance, does the expander require an overhaul, replacement of bearings at 30K to 40K hours runtime like we have in the similar refrigeration components?
I don't have it memorized. I don't know exactly when you replace the bearings, but Azelle, we will shoot you an email about that.
I'll expound on that a bit, Matt.
Will your generator affect my engine's back pressure?
Oh, absolutely not. We work with, you were talking about exhaust gas heat recovery to generate power. We work with system exhaust gas heat exchanger manufacturers, and we have some solutions that we can offer. We sized one just yesterday, and the back pressure was less than 0.1 psi. So in no way should affect an engine's performance. I know that's important for any engine operator.
All right. Would anybody else like to ask some questions or have comments to make? We can address those as well. All right. Well, if there's no additional questions, we will conclude this webinar. I did want to make one announcement about the next webinar that we will be holding. The same format, it'll be online live webinar, just like this one. It's going to be on May 17th, but of course we'll send out a reminder email to everybody who attended this one, in addition to our other mailing list. The episode number 2 is going to be called Mitigate and Generate Methane to Energy, Landfill, and RNG Solutions. And there will be more information about that coming out within the next week. And again, if you would like a copy of today's presentation, file, or video, you can send a request to sales@electratherm.com, and we will send that right over. And on behalf of ElectraTherm and our presenters, thank you for joining us today, and have a great rest of your day. Bye-bye.